Good day to you. This is teacher LELAND Alejandro, and we're going to do the slopes, finding slopes for this lesson. Now, slope is part of the equation of a given line. So we're going to learn how to determine the slopes from a given 2 points. We will also learn how to determine uh, the slope from a given line equation. Okay, and we will also find the slope for a given perpendicular line. So we shall have the examples after a little while. So we shall see our problem set. All right, check this out. All right, let's start with the first number, and we shall discuss starting with the formula for finding slopes. Now, for this particular problem, you're asked to find the slope from the given 2 points. And so we should have a formula when 2 points or coordinates of the 2 points are provided. Now, let us start with the formula for the slope. So we have for the slope m, the formula. This is a division symbol or a fraction symbol. At the numerator, you have y2 minus y1. And at the denominator part, you have x2 minus x1 there. The subtraction symbols at the numerator part and denominator part are both part of the formula. Okay, but when you're provided the 2 points, you have to put the labels first. So when you substitute those numbers in the formula, then they won't get mixed up. All right, so any point will do, whichever you want to start first. So for the given point 19 comma negative 17, or 19 for x and negative 17 for y, you may put the labels x2, y2 there. And then for the second point, you can label the negative 9 as the x1 and 15 the y1 there. And so when we use the formula, this will be direct substitution after putting the labels. You now have y2. Okay, looking at the labels that we have set up, this is the negative 17. And then minus, that's part of the formula. Get now your y1, and that happens to be a positive 15, so direct substitution, positive 15 after the minus. There. Your x2 is the positive 19, so place it over here. And then the minus is part of the formula. And then get your x1. Your x1 happens to be a negative 9, so you will have to write negative 9 after the minus. There. And so this will now be combining like terms using the appropriate sign number rules. This is going to be equal to negative 32. And at the denominator, you will have 19. Minus negative, that becomes plus. And you have something like 19 plus 9. And so this will be negative 32 divided by 28, like this. And then that is reducible to some lowest term. This will be negative 4 times 8. These are the factors of 32. And 28 is 4 times 7. There. And the 4 cancels out with the other 4. And the final answer is negative 8 over 7. There. And we shall be able to verify our answer. We shall check. There. So you can see the answer over here. And that's a negative 8 over 7, which is similar to our answer. That means this is the right slope. Now, what if you have interchanged? What if you have interchanged? So for example, let's say you have chosen this as your x2 and y2, the -9 and the 15. Let's do some different way of doing it. All right, let's clear the board. And we will remember that we use first x2, y2, the 19 and -17. All right, this time we're going to interchange the labels and see if we will get the same answer. All right. Okay, let's clear. All right, let's do it this way. Let's put the labels x2 and y2 over here. Let's use this as x2 and this the y2. And then let's use this the x1 and the y1. And let's find out if we will end up with the same answer. All right. Okay, let's start with the formula again. The formula won't change, of course. This will be the slope m y2 minus y1 divided by x2 minus x1. There, the same formula we were using a while ago. All right. Okay, so this will be y2 now. And we have the 15. And this will be minus the y1, okay? Minus the y1. The minus is part of the formula, and our y1 happens to be a -17. So this is minus -17. There. At the denominator now, you have x2 -9 minus x1, which is a positive 19. So after the minus, it's the positive 19. There. And then we'll proceed to simplification. This will be equal to, all right, remember your sign number rules. This is 15 minus -17. This will turn out 15 plus 17. And denominator, this will be added to -28 there. And the numerator, we have a positive 32. And at the denominator, we have a -28. And this will still be reducible to its factors, 4 and 8 for the positive 32, and -4 and 7 for the -28. And you see the 4 and the 4 cancels out. We will still have the answer -8 over 7. That's our answer. And this is the same as what we had a while ago. There. And you see, and you get the same answer there. So this is how to determine the slope when two given points are given. And that is regardless of how you put the labels. Okay, if you have chosen one point x2, y2, that's okay. If you have used the other one as x2, y2, it's okay. All right, so that will be for our first example. Let's continue with the next. All right, let's have our second number. All right, let's have number 2. The same instruction, find the slope of the line through each pair of points. Okay, so first thing we do is define our formula. The slope m is equal to y2 minus y1 divided by x2 minus x1. All right, so just memorize this formula. Just memorize this formula. This is the formula for getting the slope of a line. There. All right, and then we shall put our labels. Let's start with labels. This is x2, y2. The other point will have x1 and y1. Okay, so just think of this as your point 1. You can think of this as your point 1, and think of this as your point 2, like that. And those are the labels for each. All right, direct substitution. Slope m to be equal to, let's take our y2, that's 15, minus, let's take our y1. Y1 happens to be a -19. So after the minus, which is part of the formula, we will have to write -19. There, that's our y1. Now proceed to the denominator. X2 is 16 minus, okay, get the x1 now. It's -4. So after the minus, which is part of the formula, we have to write the -4 there. And then we will now simplify this point. This will become 15 minus negative means plus. So we're going to have there plus 19. At the denominator, we will have just the same. 16 minus negative, that becomes plus. There. And so this will be reduced by simplification. We're going to have 34 positive. Adding the 15 and the 19 is a positive 34. Adding the 16 and 4 gives us 20. And this looks like reducible to some lowest term. We only need to get the factors. 34 is 2 times 17. So we can express it this way. And 20 is expressible to 2 times 10. There. And you can see the 2 divides by the 2. Okay, the 2 divides by the 2. And you will have 1. 1 times 17 over 10 is 17 over 10. And that must be the answer. It's in the lowest term already, and we can verify that. There, it must be 17 over 10. Let me remove the P1 over there. There, okay? And you can see the 17 over 10 as the answer. It's over here. There, okay? 17 over 10. And that's exactly what we have. All right, let's proceed to the third example. Let's clear this out and proceed to the number 3. All right, let's have the third. Here's our third, okay? All right, let's write the formula. Always start with the formula. Slope m is equal to y2 minus y1 divided by x2 minus x1. There. And then put the labels so you will not get mixed up with the numbers. Okay, we can select this as our x2 and then y2. Remember, it's always x, the first number. After the comma, it's the y. It's always like that. And then this will be x of the first point and y of the first point. Okay. All right, so direct substitution. M is equal to, the slope m is equal to y2, it's negative 16, minus, get your y1, it's a negative 2. There. And then x2 is 17, minus, get your x1, that's a negative 7. There. And then we simplify this. This will be negative 16, minus negative means plus. And we have 17 minus negative means plus. All right, the numerator becomes negative 16 plus 2. That will have a negative 14. And then at the bottom, that will be a simple addition of 24. And this is reducible to some lowest term. Okay, negative 14 can be expressed as 2 times 7, negative, and 24 is 2 times 12. And we can now cancel out the number 2 and the other 2. We will have negative 7 over 12. And this must be our slope. All right, check it out. Let's have the answer. Let's verify it. There, it's negative 7 over 12. Okay, all right, we are correct. Let's have the next. Let's do the fourth example. Number 4. All right, let's do number 4. Okay, here's number 4. Given 12, negative 2, 5, 16. All right, the same instruction, find the slope of the line through each pair of points. All right, so start again with the formula. The slope m is y2 minus y1 divided by x2 minus x1. Don't forget this formula. This is the formula when you're after the slope and 2 given points are provided. All right, so you can label this as x2, y2, x1, y1. There. All right, let's use the formula, direct substitution. Y2 is -2 minus, get the y1, that is positive 16, and then x2 is 12 minus, get the x1. X1 is 5. And we continue. -2 minus 16, that will become -18. And 12 minus 5 is 7. And we already have the slope. That's -18 over 7. There. And this is our slope. Okay, let's check. Okay, so this is our answer, and it's the right answer, -18 over 7. Let's now continue with the next number. Okay, what do we have for the next? Number 5. Find the slope of each line. Okay, the next example, we don't have 2 points. We're presented with an equation, all right? And you'll have to recognize the type or format of the equation. Now, this looks like the slope-intercept form. Now, the slope-intercept form has this form. This is the slope-intercept form. There, okay? Where you can see the M as the slope and the B is the y-intercept. Now, for our given, you can see the presentation of the equation. Y is equal to 3 over 5x. It's very clear that the M is right here. There is the M. So therefore, the slope is 3 over 5. And you can verify that there. So it's 3 over 5. All right, so that goes to our number 5. You only need to recognize the format, okay? So don't forget this format over here. That is called slope-intercept form. The M is the slope, and the small b is the y-intercept. All right, let's continue with the next. Let's have the next problem. Here's number 6. Find the slope of each line. That's the instruction. Find the slope of each line. And we can easily recognize it. Okay, this is of the form y mx plus b, the slope-intercept form. And so you can always compare this. Y is equal to -8 over 5 x, that is plus -4. That's the meaning of that one. That part, okay? So the slope here is clearly -8 over 5. There. Check. And so we can clearly see the answer, -8 over 5. Next, 7. Here's number 7. Find the slope of each line, okay? And let's see how it looks like. This still looks like slope-intercept form. Because you have the y at the left side of the equation, and this is x minus 1. We can rewrite this so that it will look like this. This is 1 times x plus -1. There. And if you're asked to get the slope, that is clearly 1. There. That is m equals 1. And so we can verify this. And we see the slope. It's correct. Okay. All right, let's continue. Let's have number 8. Okay, let's see the next. All right, here, number 8. Find the slope of each line. All right. Y is equal to negative 4 over 5x minus 4. This still looks like the same. Y is equal to mx plus b. And we can compare the given. We have the y at the left side. We have a number and the x. And we have the minus 4. Now, if you're going to express this like the formula with a plus there, then you can write it this way. Y is equal to negative 4 over 5 x plus negative 4. It's like that. And so if you're asked to get the y-intercept, you will have to pick this out. That's the y-intercept. Now, we're after the slope. So we're going to choose the slope, which is over here. That's negative 4 over 5. And that should be the answer. All right, so we shall verify our answer. And it must be a negative 4 over 5. There. And you can see it clearly in the red numbers. It's negative 4 over 5. So this is how to determine or identify the slope from a given line equation with this format. Okay, the slope-intercept form. All right, so it's matter of familiarization to get the answers from problems like this. All right, let's continue with the next number. We shall determine the answers. All right, let's go to the next, number 9. Okay, here is the next question. Find the slope of a line parallel to each given line. Parallel to each given line. Okay, what is the nature of parallel lines? When you have parallel lines, the slope must be the same. Okay, the slope. So let's look at the graph board that we have, and let's have some examples here. Okay, going back to this screen, if I write two equations with the same slope, you will see the two lines parallel. So for example, if I write here y is equal to 3/4 x plus 7, or make that 3, there. You can see the given line passes through the y-intercept over here. This is 0, 3 point. And that's the nature of that positive 3. It's positive 3 units above the 0 there. Now, let's have a parallel line to this, passing at negative 1 right here. Okay, right here. All right. So that should be y is equal to 3/4 x, and we will have to add negative 1 there. See, it passes to the negative 1 there at 0, negative 1 here. And the lines are perfectly parallel. Why? Because they share the same slope, 3/4. 3/4. So parallel lines have the same slope. Okay, I can have one more passing through positive 5. So if we have y is equal to 3/4 x, and then we will have to add a positive 5 there. It passes to the positive 5 there. So you see these three lines, the green and the red and the blue, are all parallel. And you can notice the slope. They are identical. They're the same. All right, we can go back to our problem set. Let's go back to our problem set. Okay, here's our number 9. Find the slope of a line parallel to each given line. Or the given line is over here. Okay, and you can see it clearly. And this is of the form slope-intercept form. This is of this form. And you can verify, very well identify the slope. It's negative 1/3 x minus 2. That means this is the slope there. And the slope of a line parallel to this line shares the same slope. So therefore, our answer for the parallel line to this line is negative 1/3. That's our answer. And we shall see that from there. See, it's a negative 1/3 given in the red numbers. That's the answer. So for a parallel line, okay, when you're presented with a given equation, you just have to determine the slope from that equation, and that gives you the answer. And we have the answer over here. So you just have to recognize this format, and you'll be able to determine the slope of the line parallel to this line. All right, let's continue with the next number. Let's continue with number 10. Let's have number 10. Find the slope of a line parallel, okay, parallel to this line. All right, so you can see the format of the line. So you just have to remember the slope-intercept form, and we can say that the slope of this line is 4/3, because this is of the form y is equal to mx plus b, and this is comparable to this formula. This given is y equals 4/3 x minus 4, and you can rewrite that with a plus 4/3 x plus negative 4, like that. And so the coefficient of the x is the slope, and m is 4/3 there. And that should be it for the answer. Remember, only when they are parallel, okay, when they are parallel. And here's the answer, only when they are parallel. So that gives us the answer for number 10 question. Let's continue with the next. Let's have the number 11. All right, let's have number 11. Okay, here's number 11. Okay, I think you know the answer. Okay, all right. So we will still give the solution just the same. We will start with the formula and compare it. This is the slope-intercept form, and the given equation is very much comparable to the form there. And it looks like 1/5, because parallel lines shares the same slope. They are equal in slopes. So the slope for the line parallel to this line is also 1/5 there. And we can verify that. And it's over here. There, it's 1/5. And it's correct. Okay, so we continue with number 12. Let's have number 12. Okay, how about number 12? Okay, find the slope of a line parallel to each line. Of course, you can very well see it's -6, okay? Because of the format, y is equal to mx plus b. And you can see this is y equals to -6x plus the -3. It's like that. And so the slope parallel to this line is also having the slope -6. And that's the answer. So when you have parallel lines, the slopes are identical, and we can verify that there. And the answer is -6 there. All right, let's continue with the next type of questions. That goes to number 12. Let's have the next problem, number 13. Okay, here is number 13. Find the slope of a line perpendicular to each given line. Okay, how do you get the slope of the line perpendicular to a given line? All right, this is how you get the slope. If you have the given slope from this equation, okay, If you have parallel lines, then the slopes are the same. But if you're after the slope of the line perpendicular to this, the slope of the perpendicular is negative of the reciprocal. There. Here is the formula. It's the negative reciprocal. Okay? Negative reciprocal. All right. So let's see it from the graphing board that we're using. All right. Let's continue here. All right. The same examples are there. Okay. Now, if we're going to draw a line perpendicular to these lines, okay, we will have to use the 3/4, okay, the 3/4. Now, how do you get the slope of the line perpendicular with this line with the 3/4? You will have to get the 4/3. The reciprocal of 3/4 is 4/3, and then you will have to change the sign. Since these lines have positive, you have to make this negative there. So the slope of the perpendicular line to these lines will have a negative 4/3 slope. All right, let's have an example. Let's have an example here. Okay, y is equal to negative 4/3. Okay, say it passes to the point 0, 1. There, okay, it passes to the point 0, 1. And you can see the three lines, green, blue, and red, are parallel. Now the purple line is perpendicular. They form a 90 degrees angle here, okay? All right, so that's how to determine the perpendicular line to a given line. Use the negative reciprocal of the slope, okay? Negative reciprocal. Get the reciprocal and then reverse the sign. All right, okay. We shall do another one. Y is equal to negative 4/3. This time I will make it pass to the origin. There. By not putting any y-intercept, it will pass to the 0, 0. There. And this time, you have another perpendicular to the green, red, and blue. All right, let's return to our number 13. Let's go back there. Okay, let's continue with the problem sets. Okay, we're now ready to answer this. Find the slope of a line perpendicular to each given line. All right, for this given line, we know the slope, it's 1/2. So this is the given line, equals 1/2 x plus 3. Our m here is 1/2. Okay, to get the perpendicular slope to this line, we will have to change the sign. It's a positive 1/2. We will have to make this negative. And then the reciprocal of 1/2 is 2/1. So this will become 2/1, or simply 2 with a negative sign there. This is the required perpendicular slope. And we will find that over here. There. So the answer is negative 2 over here. That is the slope of the line perpendicular to this line. Okay. All right. I hope you were able to observe that part, and we shall try to have 3 more numbers with this type of questions. All right. Let's continue with the next. All right. Let's have number 14. Now here's number 14. Y is equal to x plus 3. So this is still in the slope-intercept form, and we can readily see the slope here. So this looks like this form. It's still the slope-intercept form, and we can see the slope, which is clearly positive 1. Because this is x, this means 1 times x, okay? This means 1 times x. plus 3. And our m here is 1. To get the slope perpendicular to this, from a positive sign here, positive, we will change that to a negative. There. And the reciprocal of 1, which is 1 over 1, is the same 1 over 1. So this will just be 1, negative. And this is the answer. And that should be it. And we have the slope of the line perpendicular to this line. There's the slope. Okay. And I hope you were able to get that part of the explanation, and we shall continue with the next. All right, let's continue. Let's have the next. We're doing number 15. Here is number 15. All right, we have a fraction here, negative 2 over 3. All right, let's start. There's the formula. Our slope here is negative 2/3. What could be the slope of the line perpendicular to this line? First, the given slope is negative, so we will make it positive. And then 2 over 3, the reciprocal of 2 over 3 is 3 over 2. So our answer is 3 over 2. There. Remember, you have to reverse the sign first to make it perpendicular, and then get the reciprocal, okay? You interchange the numerator and the denominator to get the reciprocal. So the answer here must be 3 over 2, okay? And we're correct. There. It's a positive 3 over 2 because the given slope is a negative. This one, it's a negative. So we have to reverse the sign and then get the reciprocal, okay? All right, so that gives you the slope of the perpendicular to the given line. Okay, for our last number is now number 16. Okay, here's number 16. And it's still in the slope-intercept form. So let's write our formula again. This is still the slope-intercept form. And it looks like the one in the given. Here. And if you're about to get the slope here, it's always the number beside the x. So the number beside the x is 6. Okay, we're talking about perpendicular line. So to get the perpendicular line to this line, we will have to change the sign. So from positive 6, that will become a negative. And then 6 is 6 over 1. Remember, 6 is 6 over 1. Therefore, the reciprocal of 6 over 1 is 1 over 6. There. And so the right answer is negative 1 over 6. And we shall verify that over here. There. And you can check it out. That's a negative 1 over 6. And we're correct. Okay. All right. So I hope you were able to learn how to identify slopes from equation and how to compute the slopes from two given points. All right. So in this lesson, you were able to learn how to compute for slopes when 2 points are given, and you can identify the slope when the equation is given. You also learn how to determine the slope of a line parallel to a given line, and you also learn how to determine the slope of the line perpendicular to the given line. All right, so that's all for this lesson, and see you later. Bye-bye.